The second example is still writing the n term of a sequence. We're gonna find the expression for the um for these terms right here. So my terms, my n are 1, 2, 3, 4, and on and on and on. And then every for every n, I have my term 2, -5, 10, -17. And then you notice the signs are alternating. And if you remember, the signs alternate, there is a -1 raised to n there. Okay, like what we have in the example. So let's make a t table. This is my n. This is my a sub n. So I have here 1, 2, 3, 4, and then on and on and on. Because up to n, how many you want, it doesn't matter. And then the terms are, so these are our terms, okay? A sub n is our term. So I got a 2, I got a -5, a 10, -17, and on and on and on until until I reach my a sub n that I like. Okay. Now if you notice, right away there's the sign alternates. So a sub n, our expression, there will be a -1 right away raised to n. Okay, because as the n goes up, okay, as the n goes up. So n plus 1, n plus 1, the sign is alternating, so we have to put that. You only do this if the signs alternates. And then next, I want you to look what happened here. Forget the sign. 2 plus 5, forget the sign, it's 3. 5 plus, and then 5 minus 2 is 3. Forget the sign, okay? Disregard the sign. 5 minus 5 is, no, 10 minus 5 is 5. 17 minus 10 is 7, correct? So this is my first difference. Difference 1. And you see, it's not constant. 3, 5, 7. And the next, I'm gonna do my difference 2. Meaning, my second, from the result, I will subtract. From here to here, it's 2. From here to here, it's 2. Then on and on and on. So it means that at second difference is constant. So thus, this is quadratic. Okay, I'm gonna take note of that. Since in D2, the constant, since D2, since difference 2 is the constant, thus the function is quadratic. It means power 2. X squared means power 2. Okay, so because it's power 2, then we can say that n squared, whatever your n, square it because it's power 2, then plus 1. Because just look, 1 squared plus 1, yeah, 1 squared plus 1 is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. You disregard the sign. The sign, disregard when you're getting the other parts. Okay, so -1 because the sign alternates. Well, you go back 1. If n is 0, then you go back here. You go back here 1. So 3, so that means this is a 1. Right? This is a 1 right here. The y-intercept is 1. So that's why we have here a 1. No. no, that would be, it's 3. So that would be a 1. The difference right here must be a 1. So 2, 2 plus 1. So something, if I subtract something, something, if I add to 2, will give me a difference of 1, which is, yeah, so 2 minus 1 is 1. Because 1, 3, because this should have a difference of 2 also. Because the second difference is 1. So again, guys, to get the y-intercept, go back 1. So here, you see this is a 3. So the difference of this, which we don't know yet, and this number, it should be a 1. So therefore, what is this number? What is this number that if I subtract 1 to 2 will give me a 1? And that is a 1. So therefore, your y-intercept is 1. Or follow a pattern. Okay, guys? So that's how you do it.